Bismillahirrahmanirrahim. Assalamualaikum and hello to everyone. Okay, in this topic we are going to learn about ceramics materials. Okay, I'm going to give you an introduction to ceramic materials, types of ceramic, its properties and also applications of ceramic, and a bit on the ceramic fabrication method. Okay, types of ceramic, we have oxide ceramic, silicate ceramic, carbon-based ceramic, carbide ceramic and also nitride ceramic. Ceramic in Greek known as burnt stuff. Why ceramic is known as burnt stuff? It is because for the ceramic materials, the desirable properties of ceramics are normally achieved through a high temperature heat treatment process, meaning that firing. So if we have this clay, for example, we need to firing it first. We need to dry and fire it first before we get the desirable properties. That is why ceramic known as a burnt stuff. Ceramic materials is usually a compound between metallic and non-metallic elements. It always composed of more than one element. Example, aluminium oxide, silicon carbide or silicon oxide. The interaction bonding in ceramic materials can be either totally ionic or having some covalent character or having some covalent characteristic. General properties of ceramic, we know that ceramic is generally hard and brittle. It is generally electrical and thermal insulators, exception to graphite and exception to several types of ceramic materials. And ceramic generally has high chemical stability and high melting temperature. Okay, this is the image of, this is the pictures of traditional ceramic. We use clay to make a bowl or pot. Okay, ceramics we can divide into two: the traditional ceramics and also industrial or engineering ceramics. Traditional ceramics is primarily the raw materials is clay. So example, we have porcelain, bricks, tiles and glasses. As for the industrial or engineering ceramics, which is more advanced, okay, it is a new generation of ceramics. Example, we have electroceramic, high temperature ceramic, advanced ceramic. Okay. As for the ceramic crystal structures, the unit cells of ceramics are generally more complex compared to metals. Okay, because they contain more than one element. The unit cells of ceramic often have low packing factors with low density planes and directions because of the presence of atoms of different size with mixing bonding, ionic and covalent. The unit cells of ceramic often have low packing factors with low density planes and directions because of the presence of atoms of different size with mixing bonding, ionic and covalent. So this makes dislocation motion difficult, and this limited slip of ceramics make the ceramics brittle. Okay, this is an example of sodium chloride structure. Okay, if you can see here, we have two different types of atoms in the unit cell. And another example, we have calcium fluoride. Okay, cations in cubic sites. Okay, another example, we have calcium fluoride and also perovskite, complex oxide. Complex oxide. If you can see, we have three different atoms in the perovskite. General properties and applications of ceramics. Ceramic is brittle, has high strength and hardness at elevated temperature, but low thermal and electrical conductivity. They are sensitive to flaws, defects, and surface or internal cracks. And the cracks grow through grains. Yeah? So in ceramic materials, the crack grow through grains. Ceramics fail by brittle fracture without the formation of necking or any plastic deformation. The process of brittle fracture consists of the formation and propagation of cracks through the cross-section of materials in a direction perpendicular to the applied load. Types of ceramic properties and applications. Okay, oxide ceramics. There are two major types of oxide ceramics, alumina and zirconia. Alumina, or also known as aluminium oxide, most widely used oxide ceramic. It has high hardness and moderate strength, used for electrical and thermal insulations and in cutting tools and abrasives. Zirconia oxide, or also known as zirconium oxide. Zirconia, or also known as zirconium oxide, has good toughness, good resistance to thermal shock, wear and corrosions. It has low thermal conductivity and a low friction coefficient. Used for dies for the hot extrusion of metals and zirconia beads. Silicate ceramic. Silicates primarily composed of silicon and oxygen, the two most abundant elements in the Earth's crust. The bulk of soils, rocks, clays, and sand came under the silicate classifications. The most simple silicate material is silicon dioxide, or also known as silica. So we have oxide ceramics. We also have silicate ceramics. Glass, yeah? Glass we categorize under silicate ceramic. Glass is a solid substance with an amorphous structure containing at least 50% of silica. Physically, it is hard, brittle, has resistance to electrically and heat transmission as ceramics, but usually transparent. So glass has a smooth, non-porous surface which is resistant to chemical attack. So compare amorphous silica structure. Okay, compare the crystalline silicon oxide structure versus the amorphous. The color in the glass can be obtained by adding small amount. Okay. We also have carbon-based ceramics. We know that carbon is one element, but it is a earthen element. It is an earthen material, so we include carbon as carbon in ceramic categories. Okay, carbon-based ceramics. We have diamond, graphite, and carbon nanotubes. Okay. Diamond is a principal form of carbon with a covalently bonded structures. It is extremely hard, low electrical conductivity but high thermal conductivity. It is transparent to visible light and has numerous important applications such as cutting tools, materials, abrasive in grinding wheels, dressing of grinding wheels, and dyes for drawing wires. Diamonds also we use. Graphite is a crystalline form of carbon having a layered structure with close packed carbon atoms. It is more stable than diamond at ambient temperature and pressure, but it is weak when sheared along the layers. Graphite is brittle, has high electrical and thermal conductivity, and good resistance to thermal shock. So if you see the atomic arrangement in graphite, it has a strong covalent bonds between the carbon atoms in each layer, but at the same time it has a weak force hold the layers together, as thus the graphite is more slippery. So overall, graphite has good electrical conductivity parallel to the hexagonal sheets. Carbon nanotube is tubular forms of graphite. Carbon has high strength and used as a reinforcement fiber in composite materials. It also has high electrical current carrying capability, which can be made as semiconductors or conductors. Other types of ceramic, we have carbides and nitrides. Carbides made of tungsten, titanium and silicon. Example of carbide ceramic, we have tungsten carbide, titanium carbide and silicon carbide. We also have nitride ceramics. We have cubic boron nitride, titanium nitride and silicon nitride. Example, yeah. Overall, general properties and applications of ceramics. Ceramic is brittle, has high strength and high hardness at elevated temperatures but low thermal and electrical conductivity. They are sensitive to flaws, defects and surface or internal cracks, and the crack grow through the grains. Ceramic fail by brittle fracture, which occur without the formation of necking or any plastic deformation. The process of brittle fracture consists of the formation and propagation of cracks through the cross-section of material in a direction perpendicular to the applied load. Now, ceramic fabrication method, we can divide into three, okay, glass forming, particulate forming and also cementation. Glass forming, we have pressing, blowing, drawing and sheet glass formation and sheet glass forming. This is an example of glass forming, yeah, blowing of glass bottles, pressing and also fiber drawing. Then we have particulate forming, powder pressing, hydroplastic forming, slip casting and tape casting. Under the particulate forming, we have powder pressing, hydroplastic forming, slip casting and tape casting. This is an example of particulate forming. We have like example of, this is the example of slip casting. Okay, one of the particulate forming, we have slip casting. Okay, what we do is, okay, the processing sequence, we prepare the clay and then shape of the wet clay, dry, then after that firing. So why do we need to dry and then firing? Then we have a good clay traditional ceramic. So then we have a good traditional ceramic. Third, we have cementation. Normally cementation is a fabrication method of ceramic to produce extremely large quantities of ceramic, yeah? Portland cement. Applications of ceramics. Example, we have ceramic knives, okay, made of zirconium oxide. The advantages of using the ceramic knives, it has high hardness, wear resistance, it is chemically inert, do not stain, lightweight and are easy to use. Another example is ceramic ball and roller bearings. We use it at high temperature at high speed. Yeah, so now we know that ceramic materials is not only limited to the traditional ceramic, but we also have we use these ceramic materials and we modify the ceramic materials for the advanced engineering materials. Okay, that's all for now. Till we meet again. Thank you.